When you think about a massive engineering project, your mind probably jumps straight to the action, right? The heavy machinery, the construction, but the real make or break part of the mission, that happens way before a single piece of Earth is ever moved. It all starts with the plan. Okay, let's get into it. So, think about it. How do you actually map out a journey to a target you can't even see through solid rock under pressures that could literally crush steel? It's really less like building something and way more like planning a mission to Mars, where every single variable has to be nailed down before you even think about launch. And this is where it all begins. The success or, well, the failure of the entire operation really hangs on the quality of this well-design. This is the master blueprint, the architectural drawing for a structure that's going to exist miles beneath our feet. So, long before any rig arrives, before the first pipe is even laid out, there's this preliminary mission that has to be executed perfectly. We call it the well-design process. And trust me, this is where the real work gets done. You can think of this whole planning phase as a kind of mission map. It's got a clear flow, from gathering intelligence to actually designing the well, and then finally, creating the operational playbook. So let's break this down step by step. Everything kicks off with phase 1, gathering critical intel. I mean, you would never send a team into a totally unknown environment without a ton of intel, right? Well, drilling is absolutely no different. The quality of your plan depends completely on the quality of the data you start with. So the process really starts with 2 basic steps. First, you acquire and review all the information you can possibly get your hands on. Then, you analyze it. And this isn't just about collecting files, it's about being a detective, looking for clues and patterns in the data that are going to inform every single decision you make down the line. So what kind of intel are we talking about here? Well, you've got the well proposal that basically defines the mission objective. What are we trying to do? Then there's offset data, which is so crucial. That's the info from nearby wells. You're basically learning from the successes and failures of past missions. You also consult with the veterans for their area experience, and you review all the existing geological maps and charts. All right, so once all that intel is gathered and you've picked it apart, it's time to actually act on it. And that moves us into phase 2, drafting the master blueprint. This is the point where all that abstract data starts turning into a concrete engineering plan. Now, this phase is all about collaboration. The team gets assembled for a big, well-designed meeting where literally every aspect of the mission is put on the table. The goal here is to get everyone on the exact same page and agree on who is responsible for what. Only then can the real design work even begin. And this is where those key decisions get made. Things like selecting the specific hardware, the casing, the wellhead, deciding on advanced monitoring systems, and finalizing the completion design, which is how the well is actually going to produce. And what's really important is that every single one of these decisions is meticulously documented. That creates a paper trail that ensures safety and accountability for the whole mission. Okay, so with a solid design in hand, the mission goes into its final planning phase. It's time to turn that blueprint into an actionable, step-by-step playbook that the crew on the rig is going to follow to the absolute letter. And this playbook? It's officially called the drilling program. You have to think of it as the single source of truth for the entire operation. It doesn't just say what to do, it explains exactly how to do it safely and efficiently, and it provides the technical reason for every single choice that was made. But hey, a plan is only as good as the eyes that review it, right? So the draft program gets sent around for comments from all the key stakeholders. The department that requested the well, the drilling department, other qualified experts, they all have to review it and sign off. Nothing moves forward until that final approval is locked in. So, we have a design, we have a program, we are almost ready for launch. But first, there's one final, totally exhaustive systems check to make sure every single piece of required information is there and accounted for. And this is not just some formality. This checklist is the last comprehensive review before spud-in. That's the moment the drilling actually begins. Missing even one tiny piece of this puzzle could put the entire mission at risk. First up, all the hardware gets triple-checked. We're talking about things like packers, which seal off different zones in the well, and subsurface safety valves, which are your last line of defense in an emergency. Every component, right down to the chemical recipe for the fluids, has to be perfectly specified. Next, you confirm the details of the hostile environment downhole. Engineers have to know the exact rock pressures to prevent a blowout, and they have to plan for insane temperatures. They also have to anticipate any hazards, like the potential for toxic gas, making sure every possible contingency is covered. And finally, the mission's map is confirmed one last time. All the seismic data gets reviewed to spot any geological faults that could cause a problem. The team locks in the precise coordinates, from the spot on the surface all the way down to a subterranean target that might only be a few meters wide, thousands of feet away. Incredible. So, with the playbook written and the checklist triple-checked, there's just one thing left to do: the pre-spud meeting. This is the final mission briefing, where that super detailed plan is handed out to the entire rig crew, the drillers, the geologists, the supervisors, everyone who will actually execute the mission. So the next time you see a drilling rig in action, just remember this: that physical act of drilling, it's just the final, visible chapter of a story that was meticulously written, edited, and peer-reviewed weeks, months, sometimes even years before. The success of that mission was decided in an office, not on the rig floor. And that really leaves you with a final thought, doesn't it? If this is the incredible level of detail and collaboration and planning required for just one single, well, what in the world does the master blueprint for powering our entire planet even look like?